In this video, we are going to be looking at the Accelerated 7, Unit 7, Linear Relationships, and I'm going to give an overview of linear relationships and the equation y equals mx plus b, and what the slope and y-intercept means. So we have two key vocabulary words, slope and y-intercept. Both of these vocabulary words the students do a lot of work with in this unit. Slope we like to think of as unit rate, cost or amount per, unit price, miles per hour or speed, and rate. And some examples of the y-intercept in a situation would be like the upfront fee or a deposit amount, like a security deposit, delivery fees, starting cost or startup costs, or any amount that they might already have, like if they're saving money per month and they already have $50, these would be examples of the y-intercept. So we're going to look at a few examples that the students will have in the unit. Okay, first up we have a situation where we have candy bars that cost $2 each, and we want to calculate or find how much the total cost of candy bars would be. So students will often be presented with points on a graph, and they may be asked to find the slope. Now in this case, the slope is already provided. It's $2 each. Candy bars cost $2 each. So in this situation, we already know the slope, but let's see what it looks like on the graph and how students can generate more x and y values to represent this situation. So the first thing students will do is we'll tell them to connect the dots if they have a graph, and we have them use a straight edge or a ruler, always good to have on hand, and have them connect the dots. And this is going to continue on until infinity, but we notice that this graph here starts at the origin, or 0, 0. And this makes sense because if we don't buy any candy bars, we do not have to pay any money. So that is why this is a proportional graph. It's proportional because it starts at the origin, and if we have no candy bars, we have no money cost. We don't have to pay any money. So how would students calculate the slope if they didn't know the slope? Well, we have 2 points here. We actually have 3 points, but we're going to look at these 2 points. 2 and 4, so this would be my x and my y values, and this is another good strategy students can do. They can label the graph with their x and y values so they know which is which. So if I buy 2 candy bars, I'm going to spend $4. And if I buy 6 candy bars, I'm going to spend $12. Organizing in a table is another really good strategy for students to find slope. What they learn in this unit is they learn that the slope of a line is the distance between these points on a grid. So if we look at this as a triangle, so we encourage students to use a straight edge and see if we can make a triangle with these 2 points. And you'll see that when they do this, it forms a right triangle. And then once they have this right triangle, then we can calculate the height of the triangle over the base of the triangle. So we like to think of this as the y over the x, the height of the triangle over the base of the triangle, and we're going to calculate by counting 1, 2, 3, 4. So I know I have 4 units on my x-axis, and I have 1, 2, 3, 4, 5, 6, 7, 8 units on my y-axis. So I know that I have an 8 over 4, and that simplifies to 2. So this is how we would calculate the slope. Now, as the students advance through math, they learn other ways to find slope. But at this stage, this is where they're focused on this visual representation of slope. So once they find the slope, then we come over here and we say, okay, well, if we know that the total cost of the candy bars is equal to 2 times each candy bar. So that's how we would write our equation. And our equation is the numeric representation of our problem. And we found that by finding the slope. So we know that $2 per candy bar will give us the total cost. And at that point, students can calculate and find any x and y value. We could say if I buy 10 candy bars, 2 times 10 would be 20. And I can't graph it because I don't have enough room, but they could even graph and find that their line would extend up. Now in this situation, we have no y-intercept. We kind of do. It's plus 0. This is technically the y-intercept. We show students this. This is the y-intercept. That is where our graph starts. We start with $0. If we don't buy any candy bars, we don't have to pay any money. So this is technically the y-intercept, but because it's 0, we don't need to write it. It's kind of redundant to do that. So we would just tell students that the equation would be y equals 2x. And this is an example of a proportional relationship because it starts at the origin. Now this situation is a graph that represents the depth of snow as it melts over time. So as you can see, this is a slightly different slope. This is what we call a negative slope. So we do have slopes that are negative. Before we even start, we know the slope is negative. It's decreasing. And we can also see that our graph is starting at 30. So that is the y-intercept. This is where our graph is starting. It starts at the 30 inches of snow. So we can assume that in this situation that this is how much snow is on the ground, 30. And if I want to record it in my table, I can say at 0 hours, there's 30 inches of snow. So when we start monitoring the melt at the beginning, there's 30 inches of snow. And as time goes by, it's going to melt. So we would tell students to list the points in a table. This is another way to help show any numeric patterns they can look for. And you can see that as the time increases, our depth of snow is decreasing. Therefore, it's a negative slope. And let's see if we can calculate the slope using that triangle. Now this one is a really tight, this is a real tight triangle here. I have this here. Now this is a really good example because we have different scales. So this is another thing that comes up when we're trying to find slope. We have to really pay attention to the scale because the height here of my triangle is actually 5. And my base of my triangle, my x is also 5 because each one of these is counting by 1. So this is 1, 2, 3, 4, 5. So this is tricky. A lot of times students will want to say 1 over 5, but the y is counting by 5s. The y-axis is counting by 5s, and the x-axis is counting by 1s. So this would be a 5 over 5 or a slope of 1. And what does this mean? Well, the snow is melting at 1 inch per hour, starting at the 30-inch mark. So our equation would be y equals, the depth of the snow will always equal 1 times the hours starting at 30. However, this is a negative slope, and notice our triangle is kind of backwards here. So we want to make sure we include the negative sign. And like we have discussed in previous videos, they can put the 1 in front to show that this is a negative 1x, but they could also just say negative x plus 30. The snow is melting at 1 inch per hour, starting at 30 inches.